What will our carbon footprint be in the future? Have we made progress or not? Or have we run out of time? In 2013, British Petroleum reported that Earth has enough barrels of crude oil reserves to last 53.3 years. If true, this translates to the year 2066, give or take. So what does this all mean? And what does this mean for the future? We have heard for decades that we, the people, have the whole world in our hands and the power to make a difference. We have been warned for years that the planet is in trouble and we must reduce our carbon footprint because the Earth's temperature is rising. Scientists have explained that Earth's atmosphere has a blanket. That is a thin layer of gases and helps hold in the air we breathe and protects us from the cold of outer space, therefore providing a balance of light from energy from the sun and helping plants grow. Much of the excess heat that warms the planet then reflects up through the atmosphere and into space. If Earth didn't have its atmosphere blanket, the temperature would be at freezing levels like the moon. But because of the protection of Earth's atmosphere blanket, the average temperature range is 13 to 15 degrees Celsius, or 57 to 59 degrees Fahrenheit. One of the gases in Earth's atmosphere blanket is carbon dioxide, known as CO2, and an essential part of the planet's balance of life. CO2 is what humans and animals exhale after breathing in oxygen. Plants then use CO2 and sunlight to grow and make more oxygen to help us breathe. A lot of CO2 is also absorbed by the ocean. The CO2 left over floats up into our planet's atmosphere blanket. But scientists have been reporting that the amount of CO2 has been steadily rising over the years, and the planet can't absorb all the excess CO2 trapped in the air. The planet has more CO2 than it can handle, making Earth hot, similar to sleeping with too many blankets at night. The rise in the global temperature can lead to weather conditions becoming more extreme. Wet areas get wetter, creating floods. And hot areas get hotter, creating droughts. Countries around the world have made efforts to reduce CO2 emissions and use less fossil fuels, coal, and gas, and have moved toward renewable energy sources such as electricity, wind power, and solar. In 2004, British Petroleum released a marketing campaign known as the Carbon Footprint Calculator, so people could measure how much CO2 emissions they are releasing each year. The United Nations warned in February 2022 that climate change has reached a tipping point and island nations could soon be flooded. There are approximately 27 carbon capture projects worldwide and 14 in the United States. However, critics contend that carbon capture technology is ineffective and too expensive, therefore distracting from funding projects that have been proven viable solutions such as renewable energy. Nikki Reish, the Director of Climate Programs at the Center of International Environmental Law, states the idea that this is going to be the fix to the global problem of massive emissions and accelerating climate change is just not born out of reality. It's unfortunately an attractive myth by the oil industry to perpetuate the idea that we can have our cake and eat it too. Elon Musk, founder of SpaceX, plans to launch an initiative to capture CO2 from the atmosphere and convert to rocket fuel for his private space program. Musk has announced that he will pay $100 million toward a prize to encourage the development of the best carbon capture technology. Klaus Lackner, the director of the Center for Negative Carbon Emissions and professor at Arizona State University, says it's time to draw down the atmospheric carbon dioxide or to suffer unknown devastating consequences. The International Energy Agency states on their website, IEA.org, there are currently 18 direct air capture plants operating worldwide. Capturing CO2 and an air capture plant is in advanced development in the United States. In the net zero emissions by 2050 scenario, direct air capture is scaled up to capture almost 60 million tons CO2 a year by 2030. This level of deployment is within reach, but will require several more large-scale demonstration plants to refine the technology and reduce capture costs. Howard Herzog, a senior research engineer at the MIT Energy Initiative and author of the book Carbon Capture, says it's cheaper to put carbon dioxide in the atmosphere than it is to remove it. Who is going to pay for that? Eventually, we could run out of fossil fuels and we can't grow more. Or will the day come when it's just unaffordable? For now, scientists and researchers are working to make current carbon capture technologies better. What are your thoughts? Thanks for watching and stay safe and well.